Okay. Well, thank you. It's great to be here. This is my first time here in the Middle East, first time at Abu Dhabi Sustainability Week. I was born and raised in Alaska, so very different, everything about it, population, environment, everything. And every time I go to a new place like this, it helps reestablish to me how, because of the diversity we see globally, how important it is to have a wide range of spectrum of solutions in every space, but the renewable space as well. So being here in the UAE, there's clearly solar makes a lot of sense, wind makes a lot of sense, but a lot of environments, like Alaska, solar doesn't make sense. So you need to have that variety. One thing you do have, though, everywhere you have population centers, is waste. And so I do think that the waste to energy technologies will provide a key part of reaching the renewable goals that everyone has been setting forth. So I kind of was reflecting on some of the positive impacts over the last 20 years in the waste to energy space. And really, I think it all comes down to innovation and on a variety of platforms. So over the last 20 years, there have been a lot of new financing models and strategies around investing in research and development. As Dane mentioned, our project was done in conjunction with Bill Gates. And if you look at his financing strategies previously, it was more an implementation of solutions as opposed to development of solutions. So having these new strategies for financing the development of technologies, also more integrated approaches. As these panelists were all just mentioning, there's a long way to go, but it has already begun over the last 20 years. As I get into how our technology works, it's really integrated among multiple, previously very isolated sectors. And really over the last 20 years, the tools that engineers have now to design and develop new technologies are just way beyond what they were 20 years ago. And so it allows us to accelerate the design cycle. And it's not just the modeling tools for design, but also the social modeling and the financial modeling that was mentioned in the previous panel as well. And so then from that, there's also just a lot of new technology that is going to allow us to reach the goals that are set before us. So the omniprocessor, this is the technology that Bill Gates was mentioning. And just in short, what does it do? So it was designed at its core to really focus on sanitation. So that's where the technology was focused, in processing fecal sludge in the developing world, but doing it in a way that's economically sustainable and energy is sustainable. And at the same time, if it could process other solid waste streams, that would be a plus, and eliminate all of the pathogens to clean up the environment. So that was the initial pillar that we were focusing on. But to develop a way to do it that's actually financially incentivizing to maintain sanitation, we have a few byproducts. So we generate clean water, which can be taken all the way to clean drinking standards, or could be used anywhere in between from a recycle and reuse perspective. Additionally, we generate electricity so that we can power the unit itself without requiring any access to the grid. And additionally, it produces net electricity that can be sold as a revenue stream. Third, it produces usable heat. So you could heat water for showers, you can provide steam to an industry. There's a wide range of uses for that heat. And then also ash. All of the solids in the waste are reduced to ash, and in nearly every country in the world, ash is a commodity. So through those things, it actually provides a profitable business, not just a sustainable, but a profitable business. So really, I'll just get into how the technology works as the next step. So it's a new technology, but it's really combining 3 industry standard technologies that already exist. First of all, solid fuel combustion. So we have a dryer, and we dry the incoming waste streams, and that is fed into a fire and burned. Solids are reduced to ash, and we do the combustion in a very controlled manner, and then have environmental controls and filters so that our exhausts meet all US and EU emission standard. But we didn't stop there. That got rid of the pathogens, but it didn't provide a sustainable business model. So we added steam power generation. So as you're burning your fire, you're generating heat, which can boil water, and you can take your steam from that process, run a steam engine that can power a generator so that you can sell electricity to consumers. The waste heat off of the steam engine can be fed back, and it still has heat in it. That heat is actually what's drying your incoming fuel so that you don't require a secondary fuel stream. And after that steam is condensed down to water, it goes back to the boiler to close that loop. So two really standard, everyone understands those processes. We just married them together and then added one more thing. So as you're drying the fuel, we can add water treatment. The dryer is actually boiling the waste, so the liquid portion of that waste is boiled out, and that liquid can be treated to drinking water. So while it's still in the steam phase, which makes this water treatment system unique, we filter it, then we condense it and strip all of the VOCs, and then do the final water treatment of ozone and other charcoal filters. So really, there's uniqueness in the dryer, there's uniqueness in the steam engine, there's uniqueness in filtering the steam while it's in water, or while it's still in the steam phase, but it's really three basic processes that are just very thermodynamically efficient and unique. So because there's so many potential inputs and potential outputs from this, it makes for a really robust business model worldwide, in the developing world as well as the developed world. So looking here in the developed world, currently people already pay for tipping fees. So if you were to purchase this unit, you would make money by having people bring you waste. They would pay you to take their waste. So that's the primary revenue stream. Water you could sell, but it has less value in most of the developed world. The electricity and the ash and the heat also have smaller values, although they're not, they're still worth quite a bit. So the ROI is really attractive in the developed world. And then when you move to the developing world, it also is very attractive because while you can't get a lot for people bringing you their waste, you can sell the water and you can sell the electricity, and at a much higher cost. So these are just two examples of different areas, but everywhere we're seeing really significant ROI for this model. It allows for a non-custom solution for sanitation, power, and water, because we can make the exact same unit over and over and over, rather than designing a custom power plant or a custom wastewater treatment plant for every site. And so because of that, we can provide higher value back to the customer because we can get in this mass production mode. The technology was started development phase about 4 years ago. Our first plant was deployed to Dakar, Senegal in the spring of last year and has been operating there for the last year. And our second unit, our first commercial unit, but it will be the second unit, is going to be deployed also to Dakar this summer. And we're working with a private company to do their private financing for the procurement of it, and then they're going to be operating it there. So there's still some hurdles that I see going back to the, where we should go with Habitat 3 versus what was available at Habitat 2, and particularly around this technology. There's a lot of preconceived notions about waste to energy because of the old technologies in that space. And the emissions are a big thing, and we need to take the time to educate people that there are new and better methodologies that are being used, and it's clean. We also need to de-risk the breakthrough technologies. so that we can implement them. I heard that talked about up here on the previous panel, and also the panel I was just speaking at over at Wiser with Clean Start and Prime Innovations. There's a lot of other people who are starting to look at, it's not just financing the development, and it's not just financing the back end, but it's bridging between getting a breakthrough technology that's through pilot phase and get it to commercialization. So that's definitely something that still needs to be focused on. And then furthering the integration, which is exactly where we concluded on the last panel as well, but really collaborating and integrating both the industry sectors and government, private, and individual sectors. So that's about it. I don't know if there's time for questions or if there are any questions.
Hello, Arno Krust from VITO in Belgium, Sustainable Technology Research Institute. I was wondering, this technology, I understand it has been deployed now in Dakar, in a developing country. I wonder if the return on investment is so good, why has it not been implemented in a developed country so far? And the second question is the solid, the human waste. So is this sludge after sewage treatment, or is this a human feces in a solid form? And how is it collected? So 2 questions. Thank you.
Okay. So the first question, the reason that it went to a developing world first was because it was funded by the Bill and Melinda Gates Foundation. And so their mission and their global access goals all point towards the developing world, and they couldn't put it in the developed world. We are currently in communications with hundreds of developed world potential customers, and we expect to put one there this year as well. So that is definitely where we're going with it as well. Whether it's sludge or solids, it can be really anything. So, the term omniprocessor is that it can really process anything is the goal. So it can take biosolids from a wastewater treatment plant. It can take septage directly from trucks. It can take household waste. It can take industrial waste. But really where it shines as a unique piece of equipment is processing wet waste, because there's a lot of other technologies that deal with waste to energy in the solid form, and the uniqueness is really around the wet waste.
Thank you very much. My name is David Otwoma from Nairobi in Kenya. Could you give me some idea about the volume of waste needed? And then the second question, the time it takes to break even. Is it 1 year, 10 years? Thank you very much.
The time it takes for what?
To break even, because you're saying it has a return on investment. Because in my country, I advise government, and the problem with politicians is if something is beyond their political life, which is 5 years, then they're not interested. Thank you very much.
Okay. And the first question was? The volume. So it processes the waste from about 100 to 200,000 people, a single unit, which really breaks down to about 12 bone-dry tons of waste per day. That's what's coming out of the dryer. And then, second question. Yes. So approximately 3 years is really where we're seeing in the developed world. That's assuming you're competing with diesel engine or diesel power generation, so that you could sell your electricity for just below diesel power generation prices. Your ROI would be about just shy of 3 years.
Thank you. So one of the issues in my country with waste-to-energy technology is that the mixture of waste, we have organic waste with plastics mixed together. So can Omni solve this issue? Do we have to separate the waste before we can be used with your technology? Thank you.
For the first units, it's ideal to separate out the glass and metal, but you don't have to separate out any of the food waste or any of that. That can all be fed in. But ideally, there's no energy value in non-combustibles, so anything that's easy to separate, it's better to do that.
And just one question from my side, making the link back to habitat. So what do you see as being the kind of most important government policy to improve the investment potential in, I guess, waste energy and human waste specifically?
Well, the clear, easy target for looking at an ROI, if that's where governments are looking, is to regulate tipping fees, because the volume of waste that this and other things can process, if there was a tipping fee that allowed a better ROI, you're going to get more investment. So that's a pretty tangible target.
Okay, thank you very much.
Thank you.